Juan Orlandini, and I'm here to talk to you a little bit about how to optimize your backup infrastructure. I'm going to start by describing a little bit about how backup infrastructures have traditionally been built, and then get into a little bit more as to what the new features and functionality of modern backup software packages can add to your environment. So starting off, let's talk a little bit about how we've traditionally built backup solutions. We've had, in essence, a three-tier architecture where we have a master server, and I'm using that backup terminology, substitute that for whatever backup product you're most familiar with, but the master server is the guy that controls the scheduling, the catalog information, or the index information about who got backed up, when it got backed up, those kind of things. We also have media servers. Media servers are the guys that are traditionally connected to tape resources or disk resources. And then you also have the final tier, which are the clients. So in traditional backup environments, the client environment, or the clients are defined in the environment to be associated with a specific media server. So this guy is responsible for backing up this guy, and this guy is responsible for backing up these two guys. That's done at the master server policy definition layer. It's been pretty intimately tied to it, and it left pretty much the administrator to be the intelligent decision maker as to which media server was going to be the least busy at what time. So there's been a lot of challenges associated with that, and it's led to some pretty creative scheduling at customer environments. The other thing that's happened too is starting about 10 years ago when SANs first started coming out, is we started changing our infrastructure so that we can utilize our tape and tape resources a little bit smarter. But what had happened is in the old world, a media server had his own dedicated tape drives, but if this media server had spare capacity, this media server over here couldn't utilize it because it obviously was not attached to it. So what we started doing about 10 years ago is we started putting our tape resources in a shared resource pool like this, where through the SAN, each one of the media servers can actually talk to all of the tape drives. Recently, we've also started being able to do this for our disk resources. So we might have a couple of disk resources like this, and they're also visible through the SAN to all of the media servers. But the policy definition layer still tied the client to a specific media server. This caused a few interesting effects. One of them being that as this media server aged, it became very painful for administrators and customers to actually migrate from these older equipment to newer equipment because the policy definition was intimately tied to the media server and its capabilities. Also, the problems that came up from that is that if this media server died, then these clients failed, even though I might have had the capacity to get some, if not all, of the backups done by these media servers, this remaining media server. Now, this is a pretty simple diagram where I only have two media servers. Imagine, if you will, having an environment where you have dozens, if not hundreds, of media servers, and we have customers that have that kind of scale. Doing this manual scheduling and all of that was either extremely painful for customers to do so they could optimize their environment, or it led to great inefficiencies because the environment was tuned to the lowest common denominator, and it left a lot of spare bandwidth and capacity in the environment. Well, recently with NetBackup, for a little bit with Commvault and the other packages that are now catching up, now they've actually come up with the ability to, instead of defining the policies to be a one-to-one mapping from the client to the media server, is to actually start grouping your media servers into logical containers. Now your clients themselves are mapped to the logical container instead of to the media server itself. And it's up to the master server itself to actually start scheduling and assigning the jobs to the least busy media server. There's some pretty sophisticated algorithms that determine the least busy media server, or the one that's got the most available resources, both in terms of I/O bandwidth, CPU bandwidth, and memory bandwidth, so that it can actually get the backup job done. What's nice now is that the master server policy definition, instead of mapping it to each one of the media servers manually or through some convoluted thing, you basically map it to this larger container, and then your clients themselves are automatically scheduled appropriately. The very, very nice thing about that is that if during normal operations things are running fine, and then the media server dies for whatever reason, the master server can now automatically and dynamically reassign all of the clients to the surviving media center or media server. Even better is that if your environment grows or matures as you add more capacity to your environment, you can add more media servers to this resource over here. Just grow the policy definition this way. Point your disk and tape resources to that media server as well. And you don't need to make any other changes at the policy layer up at the master server. The master server would automatically notice that there's additional capacity and bandwidth, and as jobs starts getting scheduled, it will automatically start shuffling the new load over to the media server that's been added to the environment. This is a great way for you to do rolling upgrades of your environment from older hardware platforms to newer hardware platforms, and also to, more importantly, is to alleviate a lot of the manual pain that was being felt by the administrators at the master server level of creating manual policies all the time, and offloading that to software that can do that in a policy-driven manner, maybe not quite as intelligently, but certainly much simpler and much more effective.